Hello everyone, hope you guys are doing well. So continuing our journey in Kotlin, today we will be starting with primitives. In the last we installed Android Studio and um, so let's continue. In last lecture we also saw about how Kotlin is better than Java, especially with the null pointer exception. How Kotlin has a feature to handle that. Primitive data types. In Kotlin, everything is an object, not primitive. We don't find primitives like the ones we can use in Java. This reduces the code complexity. We can call properties on any variable. For example, this is how we can. Okay, so what he's trying to say is there is no primitives. Um, Everything is an object. So this is an integer when we say code. No, this is again an object, right? Under the hood, types such as int long are optimized, but we can still call okay. Usually, this reduces code complexity. We can call methods and properties on any variable. For example, this is how we can convert int variable to a char. So I have var code int, and then I'm converting to char. Usually, whenever it is possible under the hood, types such as int long or char optimized stored as primitive types, but we can still call method. By default, the Java platform stores numbers as JVM primitive types, but when on a level member reference, for example, int is needed or generics are involved, Java uses boxed representations. Boxing means wrapping a primitive type into a corresponding boxed primitive type. This means the instance behaves as an object. Examples of Java boxed representation of a primitive types are int versus integer or a long versus long. Since Kotlin is compiled to JVM bytecode, the same is true here. The value is stored as a primitive type. The value is stored as a boxed integer or composite type. This means that each time we create a number or boolean, it will be stored as a primitive unless we declare it as a. So unless and until we make it nullable, it will be stored as a boxed representation, which is non-nullable. So, but then what he's trying to say is in Kotlin everything is an object. Let's further clarify the confusion. So does Kotlin have um reference or value types? Is it passed by reference? Will it not work? Again, use the model is going. Totally has both. But then in Kotlin, he's saying everything is an object. You don't find primitive ones. Why is this? So like, what's happening here? I see. So what is happening is actually it's primitive, but then there is a concept called as boxing or auto boxing. What it's trying to say in Kotlin. Now, what is auto boxing? Let's see. So actually these are primitives, but then because of auto boxing, they get converted to something. A wrapper class when they are used in context. No explicit primitive types in Kotlin. Even types like int, boolean, char are considered objects, though under the hood, Kotlin may optimize their representation as primitives for performance reasons when needed. Since Kotlin runs on JVM, interpolates with Java, therefore Kotlin uses autoboxing when interacting with. So what he's saying is, although this is an int, but then a wrapper is laid around it. But then that autoboxing happens only when we do non-reference, right? Java uses box separate. Boxing means wrapping a data into. By default, Java platform stores numbers as JVM, but when an enable reference, for example, is generics. Okay, so ideally these are what do you say, primitives. But then when auto boxing or something happens, when we declare it as a nullable, it kind of behaves as an object. Okay. Um, there is a caveat to this. Chasing, this is primitives. There is something called as auto boxing. So now what Kotlin does is uh, primitives to reference when needed with the help of auto boxing for performance optimization. Okay. Now when does this happen? See, when we declare values as nullable, then auto boxing kicks in. The value is stored as a primitive type, the value is stored as a boxed integer, composite type. This is a composite type. This is not what do you say? Let's do something. So when I say int, oh no, I say var a, and then when I assign it to 10. Now here this is primitive, right? When I do similarly, this is bad though. Why does that not? Oh, yeah. So when I do var a, and I make this as optional, and then I say this is in. So now this is an auto box, right? I know the question one is to be here. Okay, this is what is auto boxing. Name shadow day colon 5, and then you also this semicolon is redundant, and then you as well it's the same thing, right? Let's change it to something. Let's make this as say 20. So even though we are not printing it, but then you see this is, if you see, this is a public final class, and this is if you just does it, if I do say int, that's not required though. Explicitly number given type is redundant. Yeah. That is what he's trying to say. The numbers, basic Kotlin data types for numbers are equivalent of Java. So I have int. So okay, so he's saying you have double, float, long, int, short, byte. So basically these are in numbers. Now let's come here, and then so I have numbers. Basic Kotlin data types used for numbers, not Kotlin. Uh, so this is in short. This is double, in short, double long, and then you have byte as an in double float. Oh, I missed float. One. No, this is one. Again, however, Kotlin handles the first is there is no implicit conversions. Also, there is no smaller to bigger conversion. In Java, you can do. And then this may seem like boilerplate code, but in practice, this will allow us to avoid many errors related to number conversion, and that will save a lot of debugging time. This is actually a rare example where Kotlin syntax has more code than Java. One can do byte. Remember, type is important. However, we can explicitly specify a number you try to change to the int for type is int. Now what he's saying. Now he did talk about Kotlin handles a little bit differently. So you cannot do that conversion. But you can explicitly specify a number you're trying to change the inferred variable type. For example, so a plus literals are slightly different in some cases. There are okay. So what is a plus 1? What is it doing? 27 longs are tagged by an uppercase L. Hex are 0x prefix. We can explicitly specify a number literal to change the inferred variable type. So I say okay, inferred variable types can be changed. That means, so let's get rid of this. So I have val is, this is an int, and then I say this is 10. not this well. And then you have val b, and then you do a plus uh, this is L or I don't know, is it one? And this insert type is int. Now if I do make it long, oh, so but how does this happen? Strange, right? Mm. Is some variable depends on literal the type of or numeric type. L tells that 1 is a long value, not an int, which is a default integer type. Okay, Kotlin uses type save, ensures that types are compatible. If an int adding 1 and will result in type conversion, that is promotion. The result will be a long, as long can hold larger. But then this is possible only in infer types. Type conversion explicitly, so we can do, right? And then what is the difference? Why is this giving me an error? Is it because it is oh, so automatic conversion does not happen. You can do it explicitly. Okay, so implicit conversions does not happen. Explicit is possible. Is that what I was trying to say? Yeah, you cannot do implicit okay, in that it happens implicitly, right? Mm. What the wire went out. Let's stop. Okay. This is wrong. Okay, so let's unlike Java, implicit type conversion does not happen. And explicit is possible. Oh. Then next thing is characters. Now characters in Kotlin are stored in char, in type char. In many ways, characters are similar to strings, so we'll concentrate on the similarities and differences. Char we use single quote as opposed to okay. So is it have I written anything about char? This is let's do char and then this is single quotes. Okay. Defines a variable of type char. So character Let's check this. So if I do val char is say, okay, inference, right? So I do val char is a and the val string. So this is character, and then this is string. Now there are in both. Let's do some quotes. So say where char is single quotes, right? See, and then there's something by default. Oh, that's I don't know why, but it doesn't remove. This is really funky. Like it does not. Okay, so I guess I have to tap this maybe. Then I go add string, and then so this is string, and then this is char. Okay. Now arrays. In Kotlin, arrays are represented by array class. To create an array, you can number of Kotlin standard library functions. The simplest one is let's see the boolean type. Boolean is logic type, has two values. Null. The boolean type also supports standard built-in operations, have logical or and negation. Okay, string ranges. Okay, that's. Let's see first the boolean, and then let's So in boolean, it's small case true, and then so I do add. And then this is boolean. Okay, so you come here, you know where these are all present in standard library. So boolean also supports standard built-in operations. So this supports, this is logical or this is not, and then logical and. Okay. Then you have arrays. So arrays again, these are represented by Kotlin class. We haven't. Okay. So arrays. This is represented by array class. And then the first method to create an array is array of. So that's an info, right? By default, the function will create an array of boxed, and if you want to have an array containing short or long, so what does it do? Why does it say? What is it? So normal int will not be, when I say boxed, then does it refer to boxed int is the one that has a wrapper around it. There's a wrapper class, right? And normal int does not have the normal int does not have the wrapper. Here, even though an int Kotlin will be boxed to a integer. Okay, so array. So why is he by default? And there it's inferencing, right? This is very different. Like, again, so is it generics or something? Okay, so right now we haven't started about generic class. Just remember, if so, this array class, right? Let's move this a little bit down. So and then right now, so array array class is a generic class. So array is a, so we use this, which is a generic. T stands for data stored in the array. So it's int, then you have, okay. So first, let's code something. Yeah, this is with var, and then I do var, and this is, remember array, right? So it comes array, and then the ID shows. So now you mention what type of data is stored. So I say int by default. Oh wait, I has to be caps. I say int, and then now I do array of. So I say array of, and then parentheses. Oh, this has to be caps. Why is caps not working? Then I do array of, and then do 1, 2, 3, 4. This variable must either have a type returnation or must be in. Oh, let's change this. No, so printing is print, right? Oh, yeah, that is standard IO. So let's print. Let's run. Where is it? The variable is growing is never used. Let's get rid of this. A variable is modified so it can be declared is never modified. This is the smart thing. Although it's not a major issue. Let's comment this thing out. Oh, so let's have an append down here. Where's, oh, so the build is here, right? And then This is the terminal. So let's run. Let's just. So how to run this? Should we scratch dot sc scratch dot kts? No command found. Why? It's no. This is terminal, right? So let's just. When I run this, why isn't this is going to build the app? So I don't want to do that. Close this. This is the app. Right. Close. This is bad. How to run with that? That build is complete, right? Okay, do this. So it should run now. Okay, let's not close this. Let's add terminal. Let's read the correct. No command found. I saved this right somewhere, and then run. This was something 34 or 35, something such to be, I guess, something like that. Why did it exit? Script. Let's open. Now let's still saying no command found. Okay, let's forget that. As previously mentioned, boxed representations will decrease application performance. Kotlin has specialized classes representing array of primitive types to reduce boxing, memory overhead, so short array, int array, long array, and so on. Now, these have no inheritance relation to the array class. Now they have the same set of methods and properties. To create instance of this class, you have to use the corresponding. Now, if you want to create primitives, and avoid box. So no syntax is there are one is short of, then you do long of, and then there's double of. This is long array of. Let's go back. This is long array of. And then you have short array of. Oh, this is short array of. I missed 0. short array, and then you do int array of maybe. What happened? Okay, we can also. It's important to notice and keep in mind this subtle difference because those methods look similar but create different type representations. Generic array of boxed along elements infer type. Knowing the exact size of the array will often improve performance. We can also fill a predefined array using a factory function that takes an array. Okay, so he's saying as the first parameter and then lambda. Okay, we will discuss lambdas and okay, elements are also indexed the same way in Java, like 0 to so on. Boolean type. Now composite data type. Let's discuss more complex data types. Some data types have major compare improvements. Strings. The strings they behave the same way in Java, but they have a nicer improvements. The start to start access characters at a specified index. We can use indexing operations. Also, we have access to various extensions defined in Kotlin standard library, which make working with strings easier. This is exactly the same string class in Java, so these methods are not part of string class. We'll see what is extensions. So you're saying strings and so strings are composite. Why is it said it's a composite? No, why it's composite? Like composite in composite is made up out of two. So you're saying why is string composite? A string is composite. It is a collection. Like okay, so what he's saying is it's not string. Let's break it down as array of characters, a collection of characters. So this is string. This is a composite data type, and then when you say composite, then you say made from two things, right? It's like sequence of characters plus no, it's a collection of. I saying it's a collection of sequence of characters. Now string templates buildings. Let's define a string and let's try print. Oh no, this. Let's go to Kotlin playground, right? You can. Oh yeah, it's running good. Just come here and this is a and then we do print and then this is I pass this as an array of say one. Oh no. Okay, so this is 0, 1, and then that error might happen that it might say not used or something. Where properties never returns, it cannot. He's saying is this is something, some optimization. So he's saying that since I'm not um, reusing it, so don't declare this as a let it be van. No strings is an easy process, but in Java, long concatenation, right? For example, you have two, three strings. In Kotlin, we can greatly simplify this by creating something called a string template. Instead of using concatenation, we simply place a variable. Okay, so we can place a variable here, but in Java, you need to concatenate that variable, right? So how do we do? We place dollar. Okay, this is basically string interpolation. This happens in Swift as well. Under the compile code creates a string builder and puts all the parts together. String templates are not limited to single variables. They can also contain whole expressions between dollars, so you can do multiple things. They can also contain whole x, so you can have an expression as well between the curly braces. It can be a function called anything that returns the value or property of property access. So you can have it's a string template. So you're saying you can do string interpolation. For example, while printing, what I can do is say I can do string and then add in a value. So there is no need to perform calculation, you just do this. None of the following is applicable, so I guess we need to put a oh, inside the string I can have, yes, I think you have this as star 222 and then now this is oh, so now yeah, you have this inter then you give this as an int and let's just base it, and so you instead of using 2221, let's use the variable itself. Does it enter? No. Yes, it's a 12 has come here, so it's 1 2 3 1 2. So the string enter using the ranges. Range is a way to define a sequence of values dominated by first, and then we have something. So let's go to range. Then you have something called as range. So we do. So you can say well. These are all composite types. Range 1 to say. Insert type is int range. Notice that we are using single quotes to define the character range. So what happens is when I do int range, insert type is int range equivalent of I greater than 1 and I is less than 4. Okay, so this is basically both inclusive. You can use this in loops as well. Collections, a very important aspect in programming is working with collections. We'll discuss the subject in chapter 7. Okay. Statements versus expressions. Statements are basically Kotlin utilizes expressions more widely than Java, so it's important to know a statement is basically that returns. Sorry, an expression is something that produces a value, and then a statement is how you, yeah. So so in an expression you have operands, you have an operator, and then you assign it. Okay, so then some expressions. Control flow. Okay, statements on the other hand perform an action and cannot be assigned. So you cannot assign statements to a variable simply because they don't have a value. It's very basic, right? Yeah. So you see expressions return a value and can be assigned, right? So when you come to statements, so statements do not return a value. Then this control flow, the if statement. Okay, so I have it isn't very good in logic. Oh, I have if so control flow is there. Okay, I have okay. So I need okay. This is already written there. Let's see now. Mm, let's cut this from here. Let's arrange this. So cut it. And so let's have this pasted here. And then this can be changed. Let's cut this from here and yeah, casting right. So just paste this here. Is there any other thing that needs to go? Okay, range. Yeah, this can go here. Just cut this out as well. And we can get this thing here. Let's raise the size. And what? Let's put it on a new page itself. Let's get into a page there. So let's get rid of this new page. Trash. Then I have arrays and list, right? This is indices. this is okay. We haven't got that far. Let's first see about this any type. What's this? No, you can get this thing out from here so that it comes on a new page. Let's get this thing and let's add this thing here. Is it possible to get this thing also? Let's cut this thing. Let's delete this. Okay. So at least this is in sync, right, with what we are studying. Okay. First, let's string with this. Deal with this any type. This seems something important. So you go say any type in Kotlin. In Kotlin, it's supposed to the more general type. It is super type of all types, maintaining that any type can be assigned to a variable of type any. It is similar to the object type. It's the root of all class types. Now, what's the advantage of having any type? I mean, having any type. Okay, so this is basically like the parent of all types. This thing, this guy here, is the parent of all types. Type inference. Okay, so no, this is something not proper. It's okay then. So he's saying strings in this is much like Java, right? So let's study some about operators. So let's in let's see what does it give. So we have variety, we have arithmetic, then we have relational, then we have assignment as another one which we did. So this is something. How do we scroll? Right. There's something called as like before going on to conditionals, we should see some operators, right? Again, these are expressions, right? They will produce a value. So then first you have arithmetic. This is much like these are arithmetic, right? Mathematics. Math plus minus subtraction. Yeah, one more over here, modulo as well. You can mention that. So I guess Let's have modules and no need, right? This is addition, subtraction, division. This gives quotient. This is remainder, multiplication. Then we have relational. Then we go for then we have logical and or not. Then we have comparison operators. I think. We do have bitwise as well. Oh yeah, these are basically relational, right? Equal to, not equal to, less than, greater than, greater than. Okay. Then we have something called as assignment. So we can do. Let's. Then we can do something like assignment. So then we have. So equal to plus. And then these are all assignment. Then you have bit unary. So it's you perform unary operations, right? Unary is single, so plus minus. Then bitwise. So yeah, and this is bit by bit, and X shift left, shift right, inversion. What is USHL though? Then I have range. I mentioned operators. Range. This is just we just studied these, right? So then in, then you have not in. Then you have indexing and property access. So you do indexing. So this is square brackets. Then next you have null safety. So then first is optional chaining. Then you have always operator, and then this is first. Then again typecasting also you have to as with an optional thing. Yep. No safety operators. Then I have then I have infix. Infix function, that is index. Then I have destruct invoke operator. This is basically parenthesis. And then you have destructuring declarations. So you have component in the Kotlin's operator system is highly flexible. You can do overloading. While overloading, you can change the behavior or the way the operators behave. Okay, now let's no control flow. So let's title it. So then first is Kotlin has many control flow elements from Java, but they offer a little bit more flexibility in some cases. Their usage is simplified. Kotlin introduces a new control flow called okay, known as when. So instead of switch, you have when. Let's see what that. Then the first is again conditional, right? If else, okay, this is true. Come inside block. This is else. Just like any other if else thing. Okay, now the when. Now this is okay. So now this is something new. Now here you have something called as when expression. I don't know if when the when expression in Kotlin is a multi-way branch statement. The when is designed as a more powerful display in the switch case. The when statement often provides a better alternative than a large series of functions. The when expression matches arguments against all branches, one after the another until the behavior is similar to switch, but we do not have to write. It's like so yeah, you go when x and then okay. So there's no need for a break. So there is no fall through, I guess. So when does not have fall through, right? I guess yeah, it does not have a fall through feature in Java or C. What is matched? X is executed. Then you have else, yeah. This is like default. The when expression, its argument against all branches, similar to if class, and then Each time a branch is more than one section. Yeah, this is like similar to. So this can be anything, right? There is no thing is this and this should match. Another nice feature is the ability to check variable type. Is string is user. So I think you can do a lot of powerful things. We'll see when we get to classes. Loops. Okay, now this is no. This is I guess. Okay, so then this is loop, the for loop, classic loop again. So the classic Java for loop when to define iterator explicitly, it's not present in Kotlin. Oh, so we don't have this int loop. It is for elements in array. So it kind of takes on the elements. If a collection is a generic collection, then the item will be smart cast to a type corresponding to a generic collection. In other words, if a collection contains elements of type int, the item also. I think why I went. Oh, let's. Okay, let's see. While loop is okay. Is again. So yeah, while. So while is basically repeats a block, and in do while, first iteration is going to happen. So let's get this thing away from here. Let's cut this thing. Let's add one more page. Since in so we can say there's no classic. There is no classical follow like in unlike in Java. So the way we mention is for items in now this is uh, this is smart casting that we know. Now then so break we can break the execution flow. Now there is you can add a label as well. Fortunately, I have two form. So yeah, this is much like in C. You have labeled and unlabeled. So instead of writing break, you put the label there. We can label loops as well. Just using what just happened. Something happened though. I don't know. Let's quit this. Let's close this. Does this? I don't know. Let's only put this as a B finder. No. Is there anything left more? Exceptions. Try catch. That's no. That's all, I guess. This is again, you can have like, you have try catch and finally. So when you, so the thing is, um, the problem is you need smooth termination, right? So try, you write, you can, so then you have something called as try, and then you have try and catch, right? So you write a code here in your which can produce error, and then you handle the error here. You have finally as well. Remember, finally is optional. This is like Java thing. Yeah, finally as well. This is optional. It's not mandatory to write. Compile time constant. Since val variable is read only, in most cases we treat it as a constant. We need to that initialization may be delayed. So this means that there are scenarios when value may not be initialized. Okay. This is something tricky. Let's see what's happening here. Um, yeah, we'll see. We'll start with this in the next lecture. That's all for this one, guys. Hope you are enjoying and see you in the next one. Take care. Bye bye.